Hello guys, welcome back to another episode of Talks Writers, which is indeed the first episode of a new series about how to set up your system. And by that, we mean how to build and install various open source programs on your Linux machine. So why Linux? That's indeed a first question. Linux is free and open source, and indeed the main goal of this Talks Writer project is to use free and open source programs to perform scientific computing. And it means that our operating system should be also free and available to anyone. But there is another reason, which is from technical perspective, and the reason is most of these programs are primarily developed to be used on Linux, and installing them and building them for Linux systems are much easier than Windows or Mac systems. And that's indeed very important for us, because the user experience when we want to work with these programs are much more straightforward in Linux. And that's indeed the main reason. And also, in Linux, you have lots of freedom, let's say, a high level of freedom to control various aspects of things. And that's also essential for us, essential for our approach that we want to take to scientific computing. So in this series, we will have a short introduction on the Linux ecosystem and Linux tools and, the user experience of Linux. But then we will go on with the instructions of installing various things. But that would be more like following the instructions, because in the beginning it might be a bit scary for most of the users, because you need to work with command lines and you need to configure programs using, for example, text-based setup or text-based setting files. So it's a bit different from your experience in Windows or Mac if you're new to this. But we want to show that if following the instructions, following the provided instructions by the developers is not difficult. It's super easy, and if you follow the instructions, you can have the programs installed on your system. So for this course, what I want to do is indeed following this syllabus. So let me just make it a bit bigger. In the beginning, in the first step, I will have a very short introduction to GNU Linux, a bit of history, maybe a couple of sentences about a history, and then after that we will install one of the most favorite and easy to use distributions of Linux, Ubuntu, on a virtual machine, which will be our base, and we will build programs and install things on that. So I want a new and fresh installation of Linux, and for that purpose I will use a virtual machine. And then I will go for providing some introduction to the Linux command line interface and Bash, one of these interfaces in Linux, one of the most commonly used ones. And I will provide you with some references to know the most frequently used commands, which are pretty simple. And then after that, for the first step of installing things, I will show you how to install programs using package managers, which is it's very similar to setup wizards in Windows. But I can say that it's much easier, because you just type a command and then package manager, in this case it will be the Ubuntu package manager, will install the program for us. And then as an example, I will install GNU Octave. But for another type of package managers, maybe in another series, in another episode, I will install Visual Studio and Atom text editors as our text editor and IDE for developing source codes. And then I will show you how to install portable binaries, which is indeed one of the ways, I can say, one of the yeah, you will see a lot. For example, with ParaView, which was indeed the program that we used in the previous series for post-processing, the default installation routine is indeed downloading the pre-built binaries and adjust your system to know where the binary is and run the program, and that's it. That's pretty simple in Linux, and also the same for Windows sometimes. And as another example, for this case, for the portable binaries, I will install Solomon Gmesh, which required a bit some modification to the system. Then I will describe how to use Conda for Python virtual environments and how to install Jupyter, which is one of the tools that we need a lot, especially for the theories or for the sections that I want to describe things to you, and I want you to follow it later on. Then this is indeed these were all introduction sections. From this section, which is indeed introduction to the basics of the build process, I will start to discuss the main goal of this series, which is indeed how to obtain the source code of programs and how to build them, and why in Linux this is indeed the preferred and usually, the most convenient way for installing programs, especially if they are scientific. And then I will describe make, GNU make, and CMake, which are indeed some build system and build system generators, which make life much easier for us in this regard when we want to build something. And then I will go on with a bunch of examples from different categories to show you how to follow online instructions to install programs. For example, I will start with GNU Scientific Library, which can be built with GNU make, and then I will show you how to compile MMG, which is a very powerful mesh generator or mesh modifier using CMake, and then I will show you how to build Cgal based programs. Cgal is a very powerful mesh generator. Indeed, it's a sort of framework that encompasses and includes a wide variety of different, mesh engines and mesh classes, mesh modifiers, lots of stuff. And building programs with Cgal might be a bit tricky, but using CMake, I will show you how to do that. And then I will demonstrate a use case of GUI application, graphical user interfaces applications using Qt and CMake. And as an example, I will show you how to build ParaView. And that's indeed, you can see that even building such a complex program can be very easy. And then we will install FreeFM. We will compile and install FreeFM, which is the main tool I want to use later on for computational simulations, for finite element modeling, and for scientific computing of partial differential equations. Then I will show you how to install LAMMPS, a molecular dynamics simulator, which is indeed a very powerful one. And I want to show you how to build that from source code from scratch. And then same thing for OpenFOAM, a CFD solver, and another type of CFD approach, let's say lattice Boltzmann method with OpenLB, using still the same principles, but building that is a bit different. So in each episode, you will see a new type or a new challenge in building things. And then installing PETC, which is something I can say a framework that includes a large number of different solvers, high performance solvers, preconditioners, and those kind of stuff for high performance computing, which will be a very interesting topic. Later on, we will cover that in a series about high performance computing. And then Phoenix, which is very similar to FreeFM, but its installation, if we want to install it from source code, might be a bit tricky. And then in the last two episodes, I will describe how to install programs on university or company or some sort of commercial clusters and supercomputers if you want to use them, or cloud services if you want to install a program on that. You will see that the instruction is exactly the same. I will try to install one of these programs there, and this is indeed one of the daily tasks of scientific computing researchers. So this is also pretty essential. If I want to show you, if you face that in the future, then you know that there is no difference between installing something on a cluster and on a local machine. And then I will describe, this is indeed a very advanced topic, but when we have discussed all these things, then it might be handy to describe a bit about how to install things on old machines. And by old machine, I mean when you have, for example, old version of compilers, tool chains, and libraries. And in this case, you should know how to bootstrap the compiler, the concept of bootstrapping, which means that you compile the compiler first, use the old version of the compiler to build a new one, as well as for the libraries and those tool chains and those kind of stuff, and then use the new tool set to build the scientific computing programs. So this is indeed the syllabus of this series. I think that can be pretty cool. Just make sure to follow me on this and try to do that just with me. By following, I mean just do that at the same time that I'm doing. Pause the video and try to do the same. And we will do that on a virtual machine. So your current local installation of programs, no matter if you're working Windows or Mac or Linux machine, they will stay safe and untouched. So see you in the next video, in which we will start to install Linux on a virtual machine. So see you later. Bye.